One of the larger problems with structural simulations of plastic parts is using the manufacturing process to drive material properties of the structural simulation. Traditional analyses assume that the material properties are constant, isotropic, and homogeneous, which leads to a gross oversimplification of the material behavior in the model. Autodesk Helios PFA can bridge the gap between manufacturing simulation and structural simulation by mapping material properties, fiber orientations, and warpage predictions from an Autodesk mold flow simulation to structural simulation using the advanced material exchange. In reality, material properties are not constant, the material is not strain-free, and fiber orientations are not perfectly random. In fact, these quantities can vary widely depending on the manufacturing method, such as gate locations. The impact on the structural analysis is as follows. For fiber-filled materials, fiber orientation causes orthotropic behavior of the material, which in turn changes the stiffness of the structure. Weak areas of the structure are created where two flow fronts meet, which are known as weld lines. Residual stresses and strains can contribute to a deformed shape and a pre-stressed material prior to mechanical loading. Using as-manufactured properties within the structural simulation can only increase the accuracy of the simulation and help to identify potential areas of concern before the part is manufactured. Structural simulations have different requirements than the manufacturing simulations. Therefore, most structural models are oriented differently than those used for the manufacturing simulation, and they also have a different mesh. The Advanced Material Exchange is a utility which comes pre-packaged with Autodesk Helios PFA. Its purpose is to translate data from a mold flow simulation to the structural mesh and set up the structural model for nonlinear analysis. Advanced Material Exchange can automatically align models which do not share the same global position, as well as allow the user to interactively align models through a series of rotations and translations. Once aligned, Advanced Material Exchange also supplies the ability to check the structural mesh and identify areas in which the map data might not be as accurate as desired, which allows for mesh refinement prior to running any structural simulation. This can save valuable time and unnecessary reruns. After mapping the data, fiber orientation and residual strain can be displayed and compared on both meshes. Finally, all material data associated with the mold flow model is automatically taken into the structural model. Additional material data for elastic plastic failure simulations are entered by the user in the form of stress strain curves to failure. Most material suppliers can provide the required data, or Autodesk can recommend a testing partner to calibrate the data for use with Autodesk Helios PFA. Advanced Material Exchange will output a new input file for the structural analysis, which will require the use of Autodesk Helios PFA to generate fiber orientations, utilize any residual strains, and predict material nonlinearity and failure. The robust convergence methodology embedded within Autodesk Helios PFA allows users to simulate material nonlinearity and failure for an as-manufactured structure for both thermal and mechanical loadings.